Section 10.4, we're going to use some of the things that we already know how to do, how to simplify radicals, and we're going to add, subtract, multiply, and divide radicals. Okay? And it's sort of been this way with math since you were in elementary school. You learned about counting numbers, and then you learned how to add, subtract, multiply, and divide them. You learned about fractions. You learned how to add, subtract, multiply, divide. Integers, decimals, every set of numbers you've ever looked at, including, they aren't numbers, but polynomials. Back in Math 307, you learned about polynomials, then you learned to add them by combining like terms, you learned to multiply them by using distributive property or FOIL, division, we did long division and synthetic division. So this has been a repeated sequence of steps. So now we're experts on radicals, now we're going to add, subtract, multiply, and divide them. Maybe. All right, to add and subtract. To add and subtract two radicals, they must be like radicals. And so you might wonder, okay, what's a like radical? Like radical has the same index and radicand. An example of like radicals would be the square root of 10 and 5 times the square root of 10. Those two have the same index, they both are square roots, and they are both square roots of 10. I can add them or subtract them by doing the arithmetic with their coefficients. Okay, so if I was told to take the square root of 10 and add it to 5 times the square root of 10, up here was an and sign. This one is a plus. If I'm supposed to add them, the coefficient in front of the first one is an implied 1. So if I have one of those plus 5 of those, how many do I have?
6.
I have 6. And that is how you add or subtract radicals. And it's very similar to adding and subtracting like terms with polynomials. If I had 3 times x squared plus 5 times x squared, I'd get 8x squared. And I do the very similar thing with radicals. Now, sometimes I have to simplify the radicals before I can try to add or subtract them. So let's take a look at question number 1. It says, subtract. Simplify by collecting like radical terms if possible. And the problem is the square root of 180 minus the square root of 125. Now, right now, those are not like radicals. So I'd have to stop and say, I'm sorry, I can't do anything with those. Maybe if I simplify them, I'll get some like radicals. So I'm going to drop down here, maybe, and, okay, hang on just a second. Okay, life's good. There's my problem. Okay, and that boo-boo will show up on the recording, but if you've watched my videos, you know, nothing perfect or professional about them. All right, I'm going to drop down here and do the work that I need to do to simplify. The reason I drop down here is that one of the radicals might take 2 steps to simplify, and the other one might take 4 steps to simplify, and it gets all cluttered. So what I do is I just drop down. I don't call it scratch work, but I do call it my work. All right, the square root of 180. Can you think of a perfect square that goes into 180? How much? 9. Okay, let's just kind of work with it over here. 180 is 9 times 20, and that's a perfect square. Does 20 have a perfect square in it? 4. It's 4 times 5. 4 is a perfect square. If I multiply these two together, I get that it's 36 times 5, and 36 is the largest perfect square. Okay, so this is the square root of 36 times the square root of 5, which gives me 6 times the square root of 5. And I'm going to send that back up. Okay, now I'm going to work on the square root of 125. Can you think of a perfect square factor that goes into 125? 25. Probably don't need to do the same kind of work on this one. It's 25 times 5. So the square root of 25 is rational 5 times the square root of 5. And I'm going to send that back up. Minus 5 times the square root of 5. Are they now like radicals? Yes. So I have 6 square roots of 5 minus 5 square roots of 5, and that gives me implied 1 square root of 5, and we wouldn't write the 1. And that's my answer. So you're going to practice simplifying radicals a lot in the lesson on trying to add and subtract them. Let's look at number 2. It says to add 9 times the square root of 5x to the third plus 7x square root of 20x. All right, I'm going to skip down here to do my simplifying. The first one is 9 times the square root of 5x to the third. Well, I'm going to drag the 9 along, and I'm going to put my two radicals. 5, is that a perfect square? Does it have a perfect square factor? Nope, so I'll put it in the back. X to the third, is that a perfect square? Does it have a perfect square factor? It's not a perfect square because its exponent is odd, but I can keep x to the second and send an x back there. Let's take the square root of that. So I've got 9 times x times the square root of 5x. And I'm going to go back up and put it underneath. It is 9x square root of 5x. The other term that I have is 7x times the square root of 20x. All right, I'm going to drag the 7x along, and maybe I can simplify this. 20. It's not a perfect square, but does it have a perfect square factor? Yeah? Do y'all agree it's 4 and 5? Now the x. It's just x to the first. It's got to go back here with the 5. It's not a perfect square. So I take the square root of the perfect square factor. So that'll give me a 2. So I have 7x times 2 times the square root of 5x, or 14x square root of 5x. Square root of 5x. Now that I've done all my simplifying, would you tell me, do I have like radicals? Yes. Okay. And the problems are sort of rigged so that you do get a lot of like radicals. All right, so that's going to be part of the answer. And if I have 9x of those plus 14x of those, how many do I have? 23x, square root of 5x. So here's an application of simplifying radicals. No, I don't need to simplify radicals because I have my calculator. The square root of 20 doesn't bother me. But I might need to simplify radicals so that then I can potentially add or subtract them. All right, let's look at number 3. All right, I have 2 times the square root of 48 minus 3 times the square root of 32 plus the square root of 27. I've got some addition and subtraction, but right now these are not like radicals. Perhaps when I simplify them they will be. We'll see. All right, the first one is 2 times the square root of 48. Keep the 2. What's the largest perfect square that goes into 48? 16. Now, some of us were thinking 4, but the largest one is 16. So you could have worked with it, and I'll write this down and then I'll probably erase it. But you had 48. If you said it was 4 times 12, and that's a perfect square factor, well, 12. 12 is 4 times 3. That's a perfect square factor, and 4 times 4 is 16. So it's 16 times 3. Which means I have 2 times rational 4, because the square root of 16 is 4, times the square root of 3, or 8 times the square root of 3. All right, back up top. That's 8 times the square root of 3. And I'll write down the next term, which is 3 times the square root of 32. I'll keep the 3. Can you factor 32?
4 and 8.
Okay, 4 and 8. So 32 is 4 times 8. There's a perfect square. Is there a perfect square that goes into 8? Yeah. It's 4 times 2. Whoops, don't circle the 2. The product of those is 16, which the product of perfect squares is also a perfect square. So 16 times 2. So that's going to be 3 times 4 times the square root of 2, or 12 times the square root of 2. So it's minus 12 times the square root of 2. Last term, square root of 27. Can you think of a perfect square factor that goes into 27? 9 and 3. So it's the square root of 9 times the square root of 3, or 3 times the square root of 3, where I took the square root of 9 and got rational 3. So back up, plus 3 square roots of 3. All right, are these all like radicals? No. This one and this one are, and this square root of 2 is different. So when I do the addition, I can only combine those that are alike. So I have 8 square roots of 3 plus 3 square roots of 3, which gives me 11 times the square root of 3 minus 12 times the square root of 2. There's a lot of work involved in these problems. All right, let's look at number 4. I have the square root of 9b to the third plus the square root of 36b to the third minus the square root of 100b to the third. Right now, they're not like radicals. So let's see what we can do. All right, the square root of 9b to the third. Nine, that's a perfect square. Gets to go up front. B to the third. Is it a perfect square? No. I'll keep b squared up there and send a single b to the back radical. When I take the square root, what do I get? 3b square root of b. Second one, got the square root of 36b to the third. Perfect square factor. Square root of 36, well, I'll put it in the front. I'll keep 2 of the b factors in the front and send a single one to the back. So I have in the front 36b squared and in the back square root of b. Take the square root, 6b times the square root of b. Put it up at the top. Finally, I have the square root of 100b to the third. (100) is a perfect square, b squared is a perfect square, and that leaves me just a b to go into the back radical. Square root of the perfect square, 10b times the square root of b. Do we have like radicals? Square root of b, square root of b, square root of b. We're also fortunate that I can do the addition and subtraction with their coefficients, because those have to be like as well. All right, so I have 3b plus 6b gives me 9b, minus 10b is negative square root, negative, erase. You might think of it as negative 1b square root of b, but you wouldn't write the 1. So the final answer would be negative b square root of b. And I did misspeak a little bit earlier when I said in this section we're going to add, subtract, multiply, and divide. We only go through multiplication. Division gets its own lesson. Okay, so let's look at number 5, and then I'm probably going to skip. All right, so I have 4 times the square root of 7 over 5 plus 7 times the square root of 7 over 3. This problem turns out virtually to be an arithmetic problem. Because if I grab the fractional coefficients of those and write them out in front, I have 4/5 times the square root of 7 plus 7/3 times the square root of 7. I can't simplify those radicals. Are they like radicals? Yes. So what I need to do is do the addition with their coefficients. So I'm going to need to add 4/5 plus 7/3. And maybe you go off to the side to do that. What's the common denominator? 15. 5 goes in there 3 times, and 3 times 4 is 12. 3 goes in there 5 times, and 5 times 7 is 35. And that gives me 47/15. My answer is 47/15 times the square root of 7. But MATLAB would probably prefer that you write it back in the format that it gave you the fractions to start with, which will be 47 times the square root of 7 over 15. I don't know if it would accept this version or not. All right, there are several other, well, a few other problems where you're going to be doing addition and subtraction. Although I really don't want to do it, let's just take a look at number 9, because when you see it, you'll think, oh my gosh, why didn't she go over that one? It asks you to find the perimeter of a trapezoid, and it has this figure drawn, and mine will not really look a lot like it, but looks kind of like that. And it has 3 times the square root of 2 inches, 4 times the square root of 50 inches, the square root of 50 inches, whoops, when I touch a certain thing with the palm of my hand, it throws it into a little tizzy. Sorry about that. And the bottom is 4 times the square root of 72. Those are all inches. How do you find the perimeter of a polygon, any kind of shape? Add all the sides. So the perimeter is going to be, and you can start anywhere you want, 3 times the square root of 2 plus 4 times the square root of 50 plus the square root of 50 plus 4 times the square root of 72. And what do you think you're going to have to do before you can add those up? You're going to have to simplify. And then add up those radicals that you can add up, and I think they're all going to end up being square roots of 2. Because think about 50. Isn't it 25 times 2? 25 times 2? 72? 36 times 2. So they're all going to end up with square roots of 2. So it's basically just another addition problem. Are we okay with that one? All right. Now we're going to multiply radicals. Okay, so we've added and subtracted. You had to have like radicals. To multiply radicals, you actually don't have to have the same index, because we saw that yesterday. We could change them into fractional exponents and multiply by adding their exponents and then converting back. But the ones we're going to look at are going to have like indices. The index will be the same. But you can multiply virtually any two radicals. It's similar to fractions. You can only add them, subtract them if they have a common denominator, but you can multiply any two fractions. It's like polynomials. You can only add terms of polynomials if they have like variables, but you can multiply any of them. Same thing with radicals. All right, when I multiply, and I'm just going to talk for just a second, if I had the square root of 5 times the square root of 7, well, we've broken radicals apart. Now we're just putting them back together. We multiply and get the square root of 35. We do always ask ourselves, can I simplify that? Okay, so you'll always ask if you can simplify. And this is, let's just go ahead and look at number 10. I wish it weren't the first problem under the multiplication, but it is. It says multiply and then simplify if possible. It has parentheses, the square root of 5 minus the square root of 3, close parentheses, squared. This is in the shape of a binomial. It's not a binomial because it isn't a polynomial, but it's in the shape. Do you remember if you had x plus 7 squared? How'd you do that?
FOIL.
You could do FOIL, and most people did do FOIL. Most of you said, well, I'm just going to write it down twice and do FOIL. Product of the first, outer, inner, last, and maybe the outers and inners could be added up. There was a shortcut. Most of you didn't embrace it. Square the first one for x squared. Multiply them for 7x, but double that for 14x. Square the last for 49. You can use a shortcut here, but you don't have to. And so if you didn't do it with polynomials, it's unlikely you'll do it here either. So we're probably going to use FOIL. All right, if I'm going to use FOIL, I'm going to have the square root of 5 minus the square root of 3 times the square root of 5 minus the square root of 3. So I just wrote it down twice. Now, off to the side, in red, which makes it important, I want to remind you of something. If you have the square root of 7 times the square root of 7, what do you get? You get the square root of 49, which is, it is rational 7. Okay? If you had the square root of 3 times the square root of 3, you get square root of 9, which is 3. So what I'm going to say about multiplying a square root times itself, you can go through this step, or you can just say, oh yeah, square root of 7 times square root of 7 is 7. The radicand pops out. All right, and that might be helpful when you're multiplying these. All right, product of the first. I'm going to write it all out for this one problem. It's the square root of 5 times the square root of 5, which is, it's the square root of 25, which is 5. And you really will save yourself some grief if you will recognize that a square root times itself, the radicand pops out. Outer product. It's going to be the square root of 5 times the negative square root of 3, which gives me what? The negative square root of 15. Not a perfect square, can't do anything with it. Inner product. It is the negative square root of 3 times the square root of 5, which is, again, the negative square root of 15. The product of the last, negative square root of 3 times negative square root of 3. Negative times negative is positive. And what will I get? 3. Rational 3, plain old 3. So if I'm going to use FOIL, I'm going to get 5 minus the square root of 15 minus the square root of 15 plus a 3. Can I combine any of those? The 5 and the 3, that'll give me 8. And what about negative square root of 15? Negative square root of 15? What will I call that? If that's a 1 and that's a 1, minus 2 times the square root of 15. And I multiplied them. If I could simplify this radical square root of 15, then I would be responsible for doing that. But that can't be simplified. All right. So in that one problem, I reviewed some FOIL, talked about what it is like to multiply two different, to multiply radicals. All right, let's look at 11. It says to multiply the square root of 10x times the square root of 10 minus the square root of x. Am I going to use FOIL this time? No, I don't have 2 terms times 2 terms. What technique am I going to use? Distributive property? So that's going to give me, and if you want to, we'll just multiply it, the whole thing. Square root of 10x times square root of 10 gives me the square root of 100x. Could we go ahead and simplify that? What's the square root of the 100 factor? 10. So that's rational 10 times the square root of x. Looking back up here, it was square root of 10 times square root of 10, so it should have popped out as 10. And then the square root of x stayed in there. All right, minus square root of 10x times square root of x is the square root of 10x squared. And can I take the square root of the x squared factor? It's going to be x times the square root of 10. And if you look back up here, the square root of 10x times the square root of x, square root of x times square root of x pops out as x, square root of 10 stays. Are those like radicals? No, done. Let's look at number 12. I have parentheses, 2 times the square root of x minus 3 times 2 times the square root of x plus 4. What technique of multiplication am I going to use? FOIL. Going to use FOIL again. And if you want to, we can write it all out. You may need to and you may not need to. It's going to be 2 times the square root of x times 2 times the square root of x, which gives us 2 times 2 is 4, rational 4, not taking the square root of it. What's the square root of x times the square root of x? It's the square root of x squared, which is back to plain old x. Outer product. It's going to be 2 times the square root of x times a 4. What can I multiply in this one? The 2 and the 4. I'm going to end up with 8 times the square root of x. Inner product. I have negative 3 times 2 times the square root of x. And what do I get as that piece of the problem? Negative 6 square root of x. And by the way, am I going to be able to add my inners and outers? what does it give you? 2 times the square root of x. All right, and the last, negative 3 times 4, which is negative 12. So my product is 4x plus 2 times the square root of x minus 12. I have my first, the sum of the outers and inners, and my last. All right, let's look at 13. I have the square root of 5, parentheses, the square root of 5 plus y times the square root of 15. What kind of multiplication will I use? Distributive property. What is the square root of 5 times the square root of 5? It is plain old rational 5. Yes, it's the square root of 25, and you can write that down if you want to, but then you're going to have to take its square root and get 5. All right, what's the square root of 5 times the next term? It's going to be y. Good. Y times the square root of 75. You need to ask yourself the question, can I simplify that? And the answer is yes. So that is the square root of 25 times the square root of 3. And I just wrote that tiny there. Can y'all see that okay? So I'm going to have 5 plus, that is 5 times the square root of 3. So I'm going to call it 5 times y times the square root of 3. I had the 5 right here, the y right here, and there's my square root of 3. Can I add those two terms up? No. I know we get some weird looking answers in these. Let's look at 14. I have 4 times the square root of 7 plus the square root of 6 times the square root of 7 minus 9 times the square root of 6. What technique are you going to use? FOIL. Okay, I'm going to pause the recording, and I want y'all to do the problem, and then we'll start it going again. All right, we take a look at doing this by FOIL. The product of the first is going to be 4 times the square root of 7 times the square root of 7, which is going to give us 4 times rational 7, or 28. Yes, you could say the square root of 7 times the square root of 7 is the square root of 49, but the square root of 49 is 7. The outer. The outer product, I'm going to multiply 4 times the square root of 7 times negative 9 times the square root of 6, which is negative 36 square root of 42. Does 42 have a perfect square factor in it? All right, do y'all agree that 42, I think of 6 times 7. Does 6 have a perfect square factor? Does 7? Then 42 doesn't. Okay, so it can't be simplified. Inner. Square root of 6 times the square root of 7, which is the square root of 42. Still can't be simplified. Can we combine those?
Negative 35.
Yes, it'll be negative 35 times the square root of 42. The last is square root of 6 times negative 9 square root of 6, which is negative 9 times 6, or negative 54. So I'm going to have 28, which is the first. The outers and the inners gives me negative 35 times the square root of 42 minus 54. And this time, my first and my last were both rational numbers. So what's 28 minus 54? Negative 26, and it's minus 35 times the square root of 42. Weird answer. All right, last problem. By the way, how'd y'all do on that one? You were close. Okay, close is pretty good. Did you find your mistake? Okay. All right, number 15. We're supposed to multiply the square root of x minus 3 minus 3, I guess, times itself, because it is squared. And are we going to use FOIL? Okay. So I have the square root of x minus 3 minus a 3 times the square root of x minus 3 minus a 3. Since I'm going to use FOIL, the product of the first, it's the square root of x minus 3 times the square root of x minus 3, which gives you x minus 3. A square root times itself, the radicand pops out. Okay, outer product. The outers, it's the square root of x minus 3 times a negative 3. I'll just put the rational coefficient in front, negative 3 square root x minus 3. Inner is negative 3 times the square root of x minus 3. I hope it's no surprise to you that the outers and the inners were the same. Minus 3 square root of x minus 3. Because when you square a binomial, when you multiply something times itself, you end up with outers and inners that are the same. So it's minus 6 times the square root of x minus 3. The last is negative 3 times negative 3, which is 9. So my product is x minus 3 minus 6 times the square root of x minus 3 plus a 9. Can I do anything else to simplify that a little bit more? You got those two rational terms? So, doesn't really matter about the order. I'm going to put x, then I'm going to put minus 6 square root of x minus 3, and then plus, I have a negative 3 and a positive 9 for 6. And those are not like terms anymore, so I'm done. A lot of steps.